Okay, hi, my name is Sasha. Thank you for the wonderful introduction. The other guy over there, his name is Andrei. He's my PhD student. He helped a lot. I mentioned this right now, so I don't have time. And I will indeed talk to you about exploratory visualization of very big and very messy data sets. If you've never seen a very big and messy data set, there you go. Here's your chance to go see an example. There we go, it's live now. So if you tweet over here, then you tweet over there, I can draw a little white line connecting the two locations. What you see up there is millions and millions of those sort of lines being drawn for the Northern America, and they're all derived from real-life Twitter data. The stuff that spins frantically in the corner is a 24-hour clock. This is the sunset. When the fat arrow makes it there, the sun is going to set. And you can see the overall activity for the country slowly die down. The country falls asleep, the mafia wakes up. Eventually, the clock is going to make it all the way to the sunrise, which is this part, and then you're going to see the sun come up, and the country is going to wake up as well. First, the East Coast in frantic bursts of activity, and then it's going to slowly roll over the continent and go westwards. Now, I can sit here for a really long time. We just went through one day. We got a lot of data going on there, and you can be mesmerized. You can see all sort of fun stuff, but I digress. So now you've seen a data set like that, and if you were reading any of the positional papers in geovisual analytics and geovisualization, that sort of stuff is supposed to unlock all sort of magical opportunities for making fantastic studies about all kind of aspects of human nature, and all other good things. So let's go ahead and, for the sake of example, study something. So New York to LA is a very popular flight in the US, one of the most popular for that matter. If you grab those little white lines, they start specifically in the New York airport and terminate specifically in the LA airport, not broader cities, just the airport per se. You can see how long it took for that little white line on Twitter to make it from New York to LA. Plotted on the right is kind of a crummy stem and leaf plot of the travel times for those little journeys. So for example, this guy over here, it corresponds to one travel time of 7 hours sharp, another 7 hours, another 7 hours, actually not sharp, rounded off, but you get the point. Here's a person who made it in 6:40, another person, and so forth. Now here's a funny little trick. This is all Twitter, this is all fake stuff. But if you look up the actual travel time, the average flight time in real life between New York and LA, 6 hours and 10 minutes. And it's right up there. Now, technically, nobody forces people to tweet right before takeoff and then immediately after landing. But if you look at the data set that you got here, that's a tiny case study. It's really striking how close you get even with something that's essentially considered garbage by a lot of people. Now, here's an example of what folk often undertake. It's a confirmatory study. Had a very narrow example that shows that, yeah, sure, in a particular scenario, you're able to do something useful with that messy geographic data. There's a different approach. There's also exploratory data analysis. So when John Tukey nailed his Protestant data analysis manifest onto the door back a while ago, he postulated that the idea behind IDA, exploratory data analysis, is to give you a broad understanding of your data rather than focusing on answering specific narrow questions. The reason why you might want to have that broad understanding is, for example, to get an idea of what to do with your data, suggest hypotheses, or, for example, to select appropriate tools and models for the analysis, or most importantly, which we're going to talk a lot about today, is to assess the assumptions behind the models that you run. If your assumptions are flawed, your results are garbage. So the rest of the talk is going to be focused on exploratory data analysis as a visual diagnostic tool for whatever sort of stuff you want to do with all of that fantastic future data. There's going to be one key visual metaphor used throughout the talk. It's a scatter plot. So if you tweet it in the morning before leaving the hotel and then you tweet it from here, as you guys all do, I treat that as one movement record. And that movement record can be characterized as, you traveled over some distance that would be shown on the right, the bottom axis, and you took some time to complete this journey. That's your duration of travel. So there you go, there's your little dot. What we did is we went ahead and gathered 1 month of all geographic Twitter data that exists, that's 80 million records, and then we put together 8 million movement records out of those. We added a lot of those little dots into this chart, and this is what came out. So just to recap, the axes are still there. So this is your distance traveled. You see that quite a few of those movement records are shorter than a mile, but they become fairly long. And this is the duration of travel. You can see that quite a few of them are actually short in duration, an hour less than a minute, but they get, again, quite lengthy. There's a logarithmic scale for the data density over there. Now, you can talk about all sorts of stuff on this chart, and we'll come back to it quite a few times. But the key thing I want you to grab from it is that it presents you with visual structure. It has these lumps, blobs, if you want to think about them, whatever informal term you want to throw at it. And these blobs can now structure your exploration of the data. So the visual structure will provide the logical structure for your analysis. For the sake of this talk, I went ahead and highlighted 3 blobs for you guys. So this one I call the edge blob, this one I call the top blob, and yes, this one's the central blob. I put a lot of thinking into that. So just to hypothesize wildly right now, so what could be the edge blob? Those are journeys that are shorter than a mile, and that took about, a few minutes to maybe an hour to complete. Well, that's probably all of you wonderful people stumbling from one room to another, tweeting your NACIS updates, and, something like that could end up there. Now, of course, I have no way of knowing what exactly it is, but here's a hypothesis. What could be the top blob sort of thing? Those are journeys that are less than 30 miles in length, and they happen over a period of a day or two. Again, we have no clear way of knowing what it is, but for now, let's hypothesize that that's just your weekly Twitter updates. You go back to your job or to home, and you all keep tweeting as you do. So there you go. There's your regular plotting. We'll come back to central blob a little later. Let's go ahead and do what the chart suggests. Let's explore these blobs that were offered to us visually by means of making a map out of it. So here's a map of how the edge blob would look like. I took that pretty spinny visualization, zoomed into Manhattan and let it run for a while, then took a screenshot. So those are your short trips, and this is actually Manhattan. You can see the shape of it. The slide, the projection, little so-so, there's more detail. There's your Central Park, that's Financial District. There's a little blob over here for the Statue of Liberty, and you can actually see this too if your screen is good enough. So that's kind of cool, so you actually do see a little bit of human ante sort of thing crawling around. Let's go ahead and show the top blob, which is supposed to be your weekly, ruminations between places. And you'd expect to see more lines. There was more data there. And you do, but there's something else that starts really showing up, and that's the beauty of exploratory data analysis. You see these giant super mega places out there that everybody just wants to go to, like the Twitter mecca of sorts. Well, they're clearly not actual locations. People don't just go and take a tweet from just that one place. These are actually places in the definition that JS gives to that. Those are centroids, businesses. You check into a restaurant. In that case, you check into Financial District, you check into an area. So you weren't exactly there. You just told that you were in that area, and the centroid becomes a point, so there you are. Now, this has huge applications if you want to study human movement and if you want to make maps out of that. Because what are you really mapping? You probably thought we're mapping people, but now we're mapping essentially business locations and centroids where people might have been. And I wanted to explore more of what kind of data in terms of one or the other we got. So I came back to the key metaphor that we're using. These 2 charts, it's taken the original data set and splitting it into 2 pieces. This is all of the movement records that we got that were produced using unwrapped, still in plastic, completely virgin location data. So it's absolutely unique X and absolutely unique Y, and nobody else ever was to that place. There's quite a few. This data set is the second-hand recycled location. So every time somebody traveled between a couple places, those are places somewhere else was exactly to before. So it's probably check-in like step. The color ramps are the same. The data classification is the same. They're meant to be visually compared for density. You can see there's quite a lot of one and the other, but the shapes are not the same, and the blobs are not exactly the same. To make it easier to see, I made this. It's a difference chart. It shows you colors in red when you have more of those GPS-like places, so potentially more accurate, more personal data. And it shows you blue colors when you have more of those place check-ins. So it's that kind of recycled coordinates going on. You clearly see that they're not spread out in the same way across the chart. For example, remember the edge blob, the stumbling between the different conference room and whatever other hypothesis we had? That's primarily unique coordinates, so maybe that is actually fit for the kind of mapping where you do need unique coordinates. The top blob, you can see a little smiley face there with 2 eyes. Once you see it, you cannot unsee it. So in that case, your weekly ruminations between different places, well, you're probably checking into a cafe place, then you're checking into your work or something like that. They mostly use this place-like location. Again, assumptions of the applications of this are huge. So if you model in human movement, if you study in migration or daily commute patterns, What about accuracy, for example? What are really mapping? A human's position or human's position snapped to the nearest business that they wanted to check in, or something like that. It also makes you think in broader sense. So who produces this data? This is not like, every 10 minutes we get to take a snapshot of where you are. There's something in your life that triggers you to send a tweet that each arises inside and you can't resist it. So something here itches people's need to tweet out their precise location, and something itches here the people's need to tweet out their belonging to a place. There are different types of sharing and potentially different types of analysis. For geographic scientists, that matters. Now I can't hide the elephant in the room anymore. That's the biggest blob on this chart, the central blob. So let's actually get on with it and see what's in there. I'm not going to make a map. Map looks similar to that. We're going to do another very affordable way of data analysis. We're going to read the tweets. We read 1,000 randomly selected for the central blob. It's highlighted up there. 83% of those are job postings and ads. So why the movement? Why the geographic? Well, they are in New York, they are in LA, there are a lot of other places. When those people post a job ad, they say, oh, it's in Tacoma or it's in Seattle, and it becomes geographic. Connect enough of those, here's your movement. It has nothing to do with actual movement per se. It is basically just synthetic fictitious records. Only 6% of the biggest blob in this data set appear as regular human tweets. It's basically useless for purpose of movement analysis. For the sake of comparison, here's the top blob. We looked at it before. In this case, over half appear as regular tweets, and you can read the beautiful of them. I like the sexy savages celebrating the new year, for example. So in that case, that does seem like human data, and again, the implications are significant. It might actually lend itself and give you good analysis. For some reason, only 12% are ads and garbage in this area, so that is a place you might want to focus on if you care. The other idea that I got from looking at that is, if you run an ad business and so forth, you have a bunch of Twitter accounts to send them out, but probably not millions. There's probably a finite amount. So how many people are producing all of this data? Then let's go back again to the key visual metaphor, the scatter plot for this stuff. Here's the original data set, full and unadulterated in any way. This is a chart with the same coordinates that shows how many people contributed the data from every part of that blob. Remember the edge blob? It's very dark in blue. There are literally thousands of people slaving away to make sure you have all of this delicious Twitter data. If you look at the top blob, for every cell you get thousands, so there's millions still people generating the data in the top blob. But as you go away from that corner into the area of central blob and this weird unknown, you actually get between single digits and maybe a couple hundred users who produced all of that. These are your super users chunking out tons of data. Again, it has huge implications for analysis. You can think of it, for example, as a matter of sampling. So if you want to have some conclusions based on your data, if you only had 5 people who produced all your data, what kind of sample is that? It's good for nothing. In this case, you have millions and millions of hardworking folks, your sample is larger. It's easier to see if you recompute this into a ratio. So in this case, what I did, I took the amount of records and divided them by the amount of people from every cell. So you get this, and that's the number of records produced by each person. It makes it even more striking that, for example, the edge blob, where the good data supposedly lies, and the top blob, you essentially have every person contribute just a few movement records, and that's it. But there's many people, the whole village is working on that. Here, you get your advertising accounts and everything else. A small account makes a ton of data happen. One of the cool implications behind this, if you were to expect that you can model this data as very long trajectories, personal stories that can be connected and shown on the map, well, you ain't got any going on. Every person literally just draws a tiny white line and that's it. There are no trajectories. What you need to think about it instead, according to this, is that you put a lot of these individual lines from different people, and that forms a river. And that river can teach you something about how the movement transpired and so forth. Now, there's also this part, the densest, another elephant, the pink one this time, in the room is that blob, because we haven't talked about it before, but this is where you get insane amounts of data for very few accounts. What is that? I call it the abyss for some reasons you'll understand in a second. Roughly 50% of that is scripted messages, for example, USGS earthquake reports or internet radios. They like to attach coordinates to the data for some reason too. But the more fun part is this. 34% of it is just fascinating. This, if you know anything about internet and whatever, TCP SYN, well, that's computers establishing connectors on the network to each other, and it's being reported on Twitter by some sort of bot. Twitter networks run by all sorts of insidious Russians. They do communicate their status and success to the owners, because you can watch it on Twitter and nobody knows who's watching, so it's perfectly anonymous yet completely public. This stuff, well, it depends how thick your tinfoil hat is. This can be anything from encoded data shared publicly to somebody like me experimenting with unique numbers so I can see whether I'm getting the data I'm sending out. But again, it's roughly a third of that. Also, you know, I'll show you later, but there's some other fun stuff to that. Anyway, so to start summarizing, I have plenty of time to do that. To paraphrase the beloved leaders, you must submit. Exploratory data analysis does offer you a lot of help for things like suggesting hypotheses. To recap the examples I gave you, is like some places and activities trigger the desire to overshare in you. That's something really interesting. I know too many people who looked into that. EDA also supports selection of appropriate tools. I talked a little bit about things like trajectory-based mapping versus segment-based mapping. Having taken a look at this, you're probably going to gravitate towards the segment-based mapping rather trying to build long personal trajectories. And finally, the most important, it's about assessing of the model assumptions. So if you're trying to model data like that for any practical use, now that you know of these super users, or the notion of clear modalities in your data, so these lumps in which there's plenty and other areas in which there's few, that's probably going to be a huge driver towards your decision making about what you can and cannot do with the data set and with everything else that you got. So the conclusion, so that you're not too disheartened, is that if you remember the airport example we did a little earlier, exact data science with messy data is absolutely possible with stunning accuracy, but the devil is in the details. You do really need to invest time into flexible diagnostics of your data model assumptions, or else things are going to discombobulate and explode. So thank you. If you like to obsess over tools, here are all the tools. I have whopping 3 minutes and 30 seconds to take questions, and thank you so much, guys.